Hello. What we have here is the VEX Testbed learning platform. As you can see, this is what we're going to be using when we learn to program. It has a claw on the front. We have underneath this gear, we have the potentiometer. We have what I refer to as the right motor. We have the cortex or the brain. We have what I refer to as the left motor. We have the limit switch. We have the line follower. And then finally we have the bump switch. Now each one of these will be given a name, and I'll explain what they do as we go. In addition to that, we have a bunch of things that we're going to need to plug in. Now, let's start with what we already have. First off, when it comes to using the sensors in the VEX system, there are two types of sensors. There are digital sensors, which only register a 1 or a 0, on or off. And we have an analog sensor, which registers a range of responses. For example, our potentiometer can be turned quite a large range. In fact, it can go about a full 270 degrees. We also have the line follower, which projects a piece of light out and then reads it back, giving it a range for what it sees. So right now, it'll see more light than if I were to cover it. Whereas for our digital sensors, we only have two digital sensors. We have, right there, the limit switch and the bump switch. Those are digital sensors. So what we're going to do is we are going to begin by plugging in our sensors. So here we have the brain. And if we look at the brain, we can see across the top that it has lines for digital and analog. We also can see that it has spaces for 1 through 8 analog and 1 through 12 plus special for digital. So let's begin by taking the bump switch cord. We're going to take the cord for it. We're going to take a look at the cord, and we're going to see what it looks like. Now when we look at the cords, we can see they have a flat side and they have an exposed metal side. We can also see that going into them we have a white wire, a black wire, and a red wire. The white wire is the neutral. The black wire is, in many cases, the timing wire, and I believe the red is the power wire. It doesn't really matter which one is which, just know that all three of them exist. One is control, one is power, and one is neutral for the flow of power. You can also see that when you flip it over, there's a grooved edge. Now if you look carefully on the digital and all the other slots, you can see that there is also a grooved edge. So I'm going to take the bump switcher and I'm going to stick it into the slot for digital 1. Make sure you check it carefully because sometimes it's not where you think it is. Then I'm going to take the cord for the limit switch and I'm going to plug that into digital 2. Now once you have the first one in there, the other one should slide in easily. You can see that when we look at them, the cords are in the same order. Next, we're going to plug in the analogs. The first analog we're going to do is we're going to do the potentiometer. Now the potentiometer, it's the same way. It has the same 3-colored cord with the same ridge. This potentiometer is going to go into analog slot 1. Remember, digital is 1s and 0s, and analog is a range. Now for the second analog switch, we're going to take the line follower. The line follower is just like the analog, and it will go into slot number 2. Once you have these plugged in, you have almost all of them that you're going to need. However, there is one more thing to plug into digital. And you can see in my hand, I have the LED. The LED looks similar to the other switches, but it only has 2 prongs. That is because an LED is a digital on or off light, and it doesn't have the timing switch. Now, this goes in specifically. If you plug the LED in wrong, it may not work, or it may catch fire and burn up. Don't worry, it doesn't cause a large fire, but still, it's best if you don't do it. So let's put the LED in the digital slots number 3, right behind the limit switch. So I'm going to push the cords out of my way. I'm going to go ahead, I'm going to place the LED right in there. And you can see they all look nice and cozy there. Now, the second thing we need to worry about is the motors. The motors, we have 3 of them. We have one for the claw, one for the right motor, and one for the left motor. Let's take a look at the cord for these. Instead of the 3 wires, they have 2 wires because a motor is either on or off. And what we're going to be using are motors rather than servos. A servo can only go a limited direction, left and right, where a motor can go 360 degrees around. But since, if we look carefully at the motor ports, we notice they're all 3-hole ports, we cannot just plug these 2-wire motors in there. So what we're going to do is we're going to add a motor controller so that we can adjust the speed. Motor controllers look like this. They have a box in the middle that says motor controller, and then they also have a female end that's blue to plug into the motor, and then they have a 3-wire male that goes into the brain. So what we're going to do is we're going to plug them in together. Now you notice it's very easy to want to plug them in however they work, but these do not actually match up because once I plug them in, we have a red wire coming in one side but coming out a black wire. This will accidentally reverse the direction of your motor and could cause problems down the road. You want to make sure that like matches like, so that the exposed metal sides are both together and the flat blue sides are both together, and that the colors of the wire are consistent and match up, red to red, black to black. Now, we take the other end of this and we will stick this into the slots on the board. So I'm going to go ahead and I'm going to attach the 3 motor controllers. So once we've attached 3 motor controllers, we're going to designate where they go. Now, much like reading, I like to start from left to right, and I designate the one on the farthest left when I'm looking at the motors or the wheels facing me as being the left. So when I put these into the brain, I will put them in there with the left motor into slot 2, the right motor into slot 3, and the claw motor into slot 4. You can see I'm not using slot 1 because slot 1 is special and only has 2 holes in position instead of 3. So I'm going to go ahead here and I'm going to put the left motor into slot 2, and just like the other ones, it has that ridge that guides you to make sure you're putting it in the correct way. So the left motor is in slot 2, the right motor is in slot 3, and the claw motor will go into slot 4. Now, once you've assembled your testbed platform, you will also have 2 other things that you need to add. One is going to be an orange USB cord that is going to be used for communicating to the computer. Here we have the orange USB cord. You'll see that it's a standard USB cord on both sides. They're interchangeable. It doesn't matter which side you put in. And you're also going to have the battery. Yours may look different than mine, but one thing that is important to notice is that on the battery there is a nub at the top. You want to make sure that nub is always facing up. The battery should be difficult to put in the wrong way, but that doesn't mean somebody won't try. So on the front of the brain, the cortex right here, you will see, if I move things out of the way, that there is an on-off switch and the battery port. You can see clearly that's how they work. And on the back of the cortex, near the top, you'll see there's a USB port. That is where the orange cord will go into. All right, so let's go ahead and plug in the battery and see how it looks. Now, when you plug in the battery the first time, some of your motors might move. That's a result of a program being left in the system. So you need to be careful to have all loose hair tied back and all loose clothing put away. If you're wearing a lanyard, please take it off for the duration of working with motors. Okay, so now you can see that the lights on the brain are responding and it's telling you that it's not ready. Make sure that your brain is on. It can also be turned off. If you're using your robot and you need to reset it, you can turn it off and on again, or you can remove the battery and put it back in. So go ahead and connect the orange cord to your brain at the top. And then we are going to pause, and I'm going to cast my screen so that you can see how we program the test bed. So right now, the test bed looks like this. I know it looks a little bit like a jumble of cords, but the reality is that for what we're doing now, it's going to do the things we need it to. And you can tuck the cords away as necessary. One thing I want to point out is that the LED is right now on. That is because the brain is giving it power because it has not been told not to. All right, so hang with me while we switch to another way of viewing. Greetings. Today I'm going to show you how to set up the VEX Robotics PLTW Robot C program. I've eliminated most of the icons on my desktop, and you can see there are two remaining. We have the round Robot C 4.0, and we have this odd-shaped graphical Robot C VEX Robotics interface. For the purpose of what we're going to be doing and this class, you're always going to be using the round Robot C 4.0. Go ahead and double-click on the app and open up the program. In this class, when the program opens, it will occasionally ask you if you would like to update the program. Since you do not have administrative permissions, please do not try to update it. So I'm going to make the program go full screen. When we first open the program, it is not ready to be used with VEX Robotics yet. So the first thing we must do is we must go to the control window here and click on Robot. This is going to open up a menu. You're going to bring the mouse down to Platform Type. Here, in Platform Type, you can see there are two options. You're going to click on VEX 2.0 Cortex. Once you've done that, you'll notice that these choices over here change, but you're not done yet. Go back and click on Robot again. You're going to go to Platform Type, and you're going to click Natural Language PLTW. Once you've clicked on that, you are now using the proper setup for the VEX Robotics Robot C programming. Now, you're going to go to File, and you're going to hit Open and Compile. You're going to hit Open Sample Program. Once you click Open Sample Program, a window should appear. That window has a great deal of options for sample programs that you can use in other ways. But what we're going to do is we're going to scroll down to PLTW. If you set up the robot options correctly, PLTW should be here. If you do not set them up correctly, this folder will not appear. Once you open the folder PLTW in the sample programs, you'll find that you have two templates, Template and then Template Backup. You want to open up PLTW Template. Once you've opened this, you're going to go ahead and you're going to save this with Save As, because you don't want to save over the template. You cannot save into this folder, or should not, if you're using the school computers. Go ahead and save this to your student drive or to your documents if this is a computer that only you have access to. Rename it PLTW Template, and then add your last name. And hit Save. Now you have your own copy of the template, but we do not want you to overwrite your own template. So go ahead and do a Save As again. Now you're going to go ahead and you're going to get rid of the words PLTW Template, and you're going to label it Testbed, because we're going to be using this for the test bed. And now you can see it already has your last name, so when you turn it in, it will be easy to see. The first thing we want to do is we want to put in our project title. Our title is obviously Testbed. This title can change depending on who else you have. You're also going to have your team members. So I like to go with the classic set of team members, me, myself, and I. Put in today's date, which for me, today's date is very easy. It is 2/20. 2019. And then the section, for me, I have you put your class hour in there. Our task description that we're going to be learning about today is we will learn how to program the different parts of a VEX testbed. I know that seems very simple. Your program description or your task description should be a little more broad in future projects when in fact you are doing your design brief and things like that. You should have a better understanding. Now, looking at pseudocode. Pseudocode is where we describe the actions we want it to do. So right now, I'm going to set up what we plan to make this do. I never put the line numbers into pseudocode because I often go back and change it. So I want to have the left motor turn on for 3 seconds. The right motor turn on for 3 seconds. But I made a mistake. That's why I don't put lines in there. I want to put a pause in there. Pause for 1 second. Now, I'm going to be using the term second, but when we're programming, we are actually going to be using milliseconds. For a moment, take a second and think if you know the difference between a millisecond and a second. How many milliseconds are in 1 second? If you said there are 1,000 milliseconds in 1 second, you would be correct. Sorry, I went full Dora the Explorer there. So let's go down and let's make our pseudocode happen. What you're going to do is you're going to make sure that your robot is set correctly. So let's check to make sure our platform type is correct. I currently have VEX 2.0 Cortex and Natural Language PLTW clicked. Both of these are active, then my robot is set up correctly. To make the motor turn for 3 seconds, I need to first turn the motor on. Many people think you might find it under motors, but what we need to do is we need to go under natural language. Under natural language, you will find a couple of different options. You will find movement, and you'll find robot motion. Both of those seem like they might be the right place, but we're going to go with movement. Movement has 3 options. Set servo, and remember I talked about a servo being a motor that only goes back and forth rather than all the way around. And then you have your other option, which is set motor. Set motor is what's going to set the motor that we're going to be using. Now, if I mouse over it, you can see it gives me a bit of a piece of information. It says the range is -127 to 127. That tells me the range for speed. It also gives me some other insights as to what I can do with it. So I'm going to grab this and I'm going to drag this out here. And I'm going to set the motor. Now, the problem is that I don't know what motor port and speed are. So the first thing I have to do, once I've got this, is I actually have to go back and I have to set up my motor and sensor setup because I don't know what to put there. Make sure that when you're doing your projects that you set up your motor and sensor setup first. You can go back and edit it at any time, but it's always important to know what you're putting into where so that you have an idea of a design that you're going to be using. So if we open up motor and sensor setup, we'll see that the options that we can use are motors, analog sensors, and digital sensors. Let's do exactly what we did before, and we will set up the digital sensors first. In digital port 1, we have the bump switch, which you can call bump, or I like to call it the big red button, because of all of those movies where somebody has to press a big red button. Now you have 2 options. It can be either digital in or digital out. Digital in means it'll always be reading as on, and then when you press it, it will cut out. Whereas digital out means that it'll always be reading as off, and then when you press it, it'll be reading as on. So this would be an example of a flashlight that you would turn on and leave on versus a flashlight that hangs from your keychain and you press it when you need it and then release it. We're going to go with digital in for now for all of our sensors. The second switch we have is the limit switch. Now with the limit switch, since it is technically a bump switch type of switch or a digital on-off switch, we don't have the limit command in our way. So we will call it limit. You do not want to name things for commands that already exist. This one is also a digital in. The next one we're going to put in is what's in our third slot, which is the VEX LED. If I were to type in LED, it would not work because LED is a command. So what I'm going to name it is VLED. This way it doesn't matter what color I have. And then I'm going to use the option of VEX LED. Now the brain knows that we have an LED there. We're going to go back to analogs because that's what we did second. In the slot for number 1 for our analog, we have a potentiometer. Now, if you don't know how to spell a potentiometer, you can always set the sensor type first. The sensor type is potentiometer. So I'm going to go ahead, since I don't want to type all of that out every time, and I'm going to type potent. And then, for the second one, we have an analog sensor that is a line follower. So we go into here, and it's very easy. It's line follower. Again, since I'm lazy, I'm going to call it line. The final thing we need to set up is the motors. We have 3 of them. If you remember from before, we did not put a motor into the first port, so we need to skip down to the second port. And we're going to name that left motor. Now you can see that I capitalized the M in motor as the second word, but I did not capitalize the L in left. This is something called camel case, and it's often used in programming. So let's go ahead and we're going to set this up as a 3-wire motor. Let's do that for right motor and claw motor as well. So right motor and claw motor. Go ahead and make those 3-wire motors as well. Now you can see off to the right, there's some options, whether we can choose to have the motor run reversed, or we could use any of the other settings that are in here. We're not going to use any of those for now, we're just going to use what we have. Go ahead and hit apply, and you can see that we've added all the pragma statements to your programming. Now the computer knows what we're talking about. Go ahead and save it just to make sure. So now when I come here and I double click on motor port, if I were to type in left motor, it now knows what I'm talking about. And what was the range that I could use? If we go back and we look, you'll see that it goes from negative 127 to 127. If I were to type in 127, that would be full speed. If I wanted it to go the other direction, I would type in negative 127. And if I didn't want the motor to move at all, I would put in 0. Now here's a fun fact. This gives us a total range of movement of 255 different points that it can be put to. 127 in one direction, 127 in the other direction, and 0. That brings us to 255. That is because 1 byte of information consists of 8 bits, and in binary, 8 bits can be stored or can be displayed to use 255 different potential options. So the speed uses up 1 byte of information. I know that's not important to what we're talking about, but it's a neat fact. So we now have 127 as our top speed, but if I type in 500, the computer will actually give it a yellow X and tell me that it's incorrect, and it'll read what it knows how to do. So I'm going to go ahead and I'm going to compile the program, and it gets a yellow X. If I were to type in instead of 500, I was to type in something like cat, which is not a speed, it is an animal. I would get a red X saying that the code could not function. So with a yellow X, it will function by automatically correcting, but with a red X, it will not function at all. I'm going to go ahead and put in 127 for our speed and compile the program to remove the X. Now, if we were to hit start by sending the program to the robot, I would hit download to robot. Confirm any messages you have, and you'll be set. So right now, the program is in the robot. If I hit start, the motor should go full speed. Wait, I hit start. Why is nothing happening? That is because the program is ending as soon as it starts. For the motor to work, I need to tell it to wait. So what I'm going to do, I'm going to move this down a little bit because we'll need this space later, and I'm going to tell the program to wait. So if I go back to natural language, I have under the subcommands one called wait. You have 2 types of wait commands. Wait, which is in seconds, and you have wait, which is measured in milliseconds. You want to use the wait in milliseconds for all of your programming because it's more precise. So if I want it to run, as the pseudocode says, for 3 seconds, my wait time would be replaced with, correct, 3,000 milliseconds. Now, let's try downloading it to the robot and see what happens. There you go. You have now made the robot move. If you hit start again, the robot will move again. All right. So, if we want to pause for 1 second, as our pseudocode says next, let's go back and we'll grab another wait command. So right now, the robot is waiting, and then for 3 seconds it'll run the motor, and then it's waiting. So let's go ahead and we're going to add that 1 second pause. 1,000 milliseconds is 1 second. Let's download the robot and see what happens. Now count with me when the robot runs. 1, 2, 3, 4. Why did the robot run for 4 seconds instead of 3 and then waiting for 1 second? That's because we didn't tell the motor to stop. A robot can only do exactly what you tell it to do. So let's go ahead and put in a robot motion or a movement command for stop motor. You need to tell the robot to stop moving the motor. The reason it stopped earlier is because the program ended. But now, since we're having the motor stop, we need to do something else afterwards. We need to tell it to stop. So our stop motor command has the motor port, and the motor we're using is the left motor. Now you notice here, it already noticed that I'm using the command left motor, and it brings it up automatically to make my life easier. So now when we run this, we can have this run for 3 seconds, and then it will pause for 1 second. But our pseudocode says that it's going to run the left motor for 3 seconds, pause for 1 second, and the right motor for 3 seconds. Now, to make that happen, we can either grab all of the individual pieces of code from here and rebuild it, or we could be smart programmers and take a function that we've already created, copy it, paste it, and then just change parts of the command. So I change my left to right. Same thing here. I change my left to right. So the way the program reads, I will now have the left motor start and run for 3 seconds. Then it will stop. Then it will wait for 1 second. Then the right motor will start at full speed and run for 3 seconds, and then it will stop, and then the program will end. Let's see if that's what we have. Okay. So like I said, when you download the program to the robot, it automatically saves it, so be careful of what you're saving. So let's start the program and see what happens. Our left motor is moving for 3 seconds, 1 second pause, and then our right motor moves for 3 seconds before it stops. Now, that is a basic program. It does exactly what we want it to do. But let's look at some of the other things we can add. Now, I'm not going to add anything to the pseudocode because I want to focus more on the commands. You can add to the pseudocode as you go to add anything that you need to add in there. Which, by the way, pseudocode, you notice, uses the asterisk and then forward slash, followed by the, forward slash asterisk to start a large chunk of pseudocode and an asterisk forward slash to end it. If I wanted to get rid of a line from the code itself, I can use a comment command called 2 forward slashes to comment that line itself out. So if we comment out the wait, and then we send the program to the robot again, let's see what happens. Here, the motor turns, and as soon as it stops, the other motor turns. It skipped over the command. So that's what happens when you can comment out code. So let's put that piece of code back in there. We're going to need it later. All right. Now, there are many different ways in which you can start your robot moving. All of your robot commands, though, I need to reiterate, come between these squiggle brackets at the top and bottom of your task main. So let's go ahead and take a look at some of the commands we can add. If we open up natural language, any of the commands to start it are probably going to come under until. So one of the common mistakes that people make is they go until button press for using the buttons over there. However, that button press, if you read it, says that it's for an LCD screen. We do not have an LCD screen on this robot, so you're going to use until bump. Until bump is what we use for our digital switches. So let's take a look. We're going to drag until bump out here, and we have two different bump switches. So let's drag a second one out here. Now, the first bump switch we have is the one I called BRB. And the second one is the limit. Now, the delay time is how long between when the button is pressed, or the bump switch is pressed, and when it can read the next command. You usually want to make this a little bit longer so that you don't accidentally milk the switch and have it pressed twice. So I like to put the delay at about 50 milliseconds. Sometimes if I'm doing one of the challenges, I'll make it 500 so that I don't accidentally press it twice. So now, when we send this to the robot, we're going to have a little line to follow. Now we can see here that when I hit start, nothing's going to happen. Now the green line is telling you what's next. It's waiting for me to finish this command. It's waiting on the next line. So once I press the bump switch, the BRB in the back, the green line will move down. But now it's waiting for me to press the limit switch before anything moves. So I'm going to press the limit switch. You can see that once that was pressed, the program goes through. All right. So those are the two switches that we have that are digital. We also have two analog switches. So let's go ahead and we're going to add in the analog switches as well. If we go to the until, the first analog switch we have is a potentiometer. Potentiometer has two choices, potentiometer greater than and potentiometer less than. I'm going to go with greater than for now. You can go with either one. Potentiometer greater than has a position reading. That position reading we're going to find when we run the debug mode, and we're going to talk about that in just a second. So I'm going to set the position reading at 2000 right now, because 2000 is right around the middle of the potentiometer's reading, and we named the potentiometer potent. So this gets a little confusing. With the bump switches, they were name of the sensor first and then delay time. But with the analog switches, it's actually the threshold reading first and then the name of the switch. Make sure you get those correct. If you're not sure, you always have the examples here to look at. So let's grab until dark, and we're going to put that under potentiometer. Until dark is for the line follower. So let's make sure we're clear about that. I'm going to add a comment. Notice I can actually comment after the code, and it won't show up in the reading of the code, but it still shows up so that a programmer could read it. This allows the programmer to leave notes for other programmers. So let's take a look. The threshold for until dark, we're going to set at, I think 2000 should work as well, and the sensor port will be line. So let's go ahead and test this out. We're downloading it to the robot. Now before we hit start, I want to show you how to add the debug windows. You notice that right here we have the debug window, but there's nothing useful coming up. If we go to robot, we can add the debugger windows. I like to add sensors, and I like to add motors. Now if I were to mess with these, I could turn the power on for this motor to test to make sure it works. If I turn the power to 50 and I hit enter, the motor will run. I have to turn it to 0 to make it stop. If I go to sensors, we can see that we have the range of sensors right now. So right now the potentiometer is turned all the way off. If I were to reach over the potentiometer and I were to adjust it, you will see that on the screen it goes up and down. So I'm going to leave it back at all the way off. And currently the line follower is reading 250. If I were to cover it, it apparently is still reading 250. So that makes me say that the line follower must not be plugged in correctly. So let me go to it, and look, the line follower actually was not plugged in correctly. It had come loose. So now that I plug it in again, the line follower is reading about 3,000. So if I test it, I cover it up, it drops to about 600 and 700-ish. So let's go ahead and we're going to run our program. Oh, one more thing. The digital sensors, you can see, are currently reading 1, but when I press them, they read 0. And if I change the LED, it's currently off. If I were to make that a 1, the LED would turn on. So let's go ahead and run our program. So now it's waiting for me to press the bump switch. Now when you see me press the bump switch, also check to see what the debug mode is doing. You can see that I pressed it. And again here. So now we're waiting for the potentiometer to turn up above 2,000. Watch the potentiometer in the debug window. Now it automatically turned on for the line follower. So by saying until dark, it's essentially the version of until greater than. So I'm going to run the program again, but this time I'm going to cover the line follower. So let's see what happens again. First, I need to turn back down the potentiometer. That's a mistake I make frequently. I press the big red button. I press the limit switch. I turn up, put my hand over the line follower, and with my other hand, I turn up the potentiometer. The potentiometer is above 2,000, but the line follower is not reading greater than. Now it is. Now the program goes. That is how you control the commands for each one of the robots, different inputs. The final thing that I haven't shown you to do yet is the claw. Similar to when we were making the motors run before, we want to make the claw motor run. And just like then, I'm a smart, lazy programmer. So I take the commands for the left and the right wheel, and I'm going to copy them. I'm going to go down here, I'm going to paste them. Now, I'm going to change this from left motor to claw motor. I'm also going to slow it down because the claw motor, if it opens at full speed for 3 seconds, it will make a high-pitched whining sound because it is being broken. So I slow it down to 1/3 speed, or roughly 40. I'm also going to run it for half a second, or 500 milliseconds. And then it's going to stop the claw motor. It will remain open for 1 second. Now, if I'm running it at +40 to open the claw motor, I need to run it at -40 to close the claw motor. So go ahead and adjust the name, claw motor, at -40. Also run it for half a second, or 500 milliseconds, and then adjust the name on the stop. So now, when we run this, the whole thing should happen. So I'm going to go up to the top, and I'm going to comment out all of the different starting points other than the BRB. So I'm going to comment out these so that we just have to press the BRB to start the motor process. So let's send this to the robot. You can see it skipped all the commented lines and it's waiting for me to press the BRB. There you go, and that's the program. We're going to make one minor change though. Here you can see that I have cleared space so that you can see the LED and the claw motor move at the same time. What we're going to do is we're going to have the LED turn on at the beginning and turn off at the end. So let's go back to our natural language. We're going to go with special for LEDs because you have them in here. You have turning LED on and off. So let's grab that and we're dragging it out. So once the bump switch is hit, the LED will turn on. If you remember, we named our LED VLED. And if we go to the bottom, we need to make sure that we put this into the commands. We do not want to put anything outside the squiggly brackets for the task main. So let's grab the turn LED off command and make sure we name it VLED. If we download this to the robot, you will see that it will turn on and off when we run it. Now, when I hit the bump switch, it's waiting for me to turn this on. The LED has turned on as the program runs. And then the LED turned off at the end of the program. There is one last command I want to teach you, and there's two parts to it. There is the main part of the while command, and then there is the conditional part of the while command. So let's go ahead and we're going to add the main part. Now, most of your commands so far have been natural language, but a while command is a control structure. And then you find it under control structures, and then again in the subcategory of control structures. You can see that if I were to drag the while command into the program, it has the while command, it has a condition, and then it has a placeholder for body between the squiggle brackets. What we're going to do is we're going to delete body, and we're going to delete the bottom squiggle bracket. We're going to add the bottom squiggle bracket down here. This way, everything that's in here is contained within the while command. Now, the condition in a while command can be set in a couple different ways. It can be set to true, which means that it's always going to run, which means that when this program ends running, it will start over. It creates a loop. A loop is where a program does something over and over again as long as it's true. The other method, which we're going to use later, is called a conditional. In the conditional, you are going to run until a certain condition is met, and then it will break the program. It'll break the loop. So for now, for the overall program, we're going to make the condition true. You could also make this, instead of true, you could make it 1 equals 1. I prefer true because it's easier for most people to understand. Oop, true. Now, when we do this, the program's going to run over and over again. I'm not going to test it out because we know what it looks like. What we're going to do instead is we're going to add a second while command down here, and this one is going to have a conditional. I'm going to drag out the while command, and I'm going to make the conditional. Now, the conditional goes like this. Sensor value. You can see it pops up, sensor value. And then I'm going to create a box that names the sensor. And the sensor I'm going to name is potent. Actually, I'm sorry. I'm not going to use potent. I'm going to use limit. So I'm going to use box brackets, and then I'm going to put limit in there. And then I'm going to make it equals 1. So that while the limit switch equals 1, what's in here will continue to run. So in here, I'm going to make the left and right motor both run. So I'm going to go back to natural language, and I'm going to make robot motion, not robot motion, movement, and I'm going to pull out the commands. I'm going to pull out 2 start motors. Now in here, I'm going to make left motor, speed be 127. I'm going to make the right motor speed be negative 127. I got to make sure I name it right motor. Now, to make sure that the motors stop afterwards, that once the loop is broken, I'm going to put in the stop motors. I don't want to put the stop motors into the while loop because it'll read them and start and stop instantly. So I always have the command that stops whatever happens in the while loop outside of it, because once it's broken, it will read that command next. Left motor and right motor for the stop. All right, so what's going to happen is I'm going to download this program to the robot, and then as long as the sensor values, it's going to run like normal, but as long as the sensor values on the limit switch is 1, the left and right motors will continue to run. So let's move this out a little and see what happens. I'm going to start the program. I'm waiting. I press the button. Now the program runs as normal. Now they're both running. Now you can see that it's running over and over until I press that. And now the first while command has brought us back to the start, waiting for me to start it all over again by pressing this. I'm going to stop it midway. The one other command I'd like to show you is a line break. You can have a program run partial by clicking on the line for the command you want it to stop at. So now when I run the program, I download it to Robot, with that line break in there, it will run the program until it hits this red line, and then it will stop. So let's take a look. This is used for testing program parts. And that's called a breakpoint. So there we have, I can have it resume if I would like to continue. That becomes important for testing parts of your programming. Okay, so now that we've learned all of that, you've learned everything you need to know in order to program a robot. There are a few commands that you don't know, but don't forget that you can always look them up on Google. By Googling VEX space PLTW and then the name of the command that you would like to learn about. And there are PDFs out there for every command. You can also speak to your instructor and see if they have any guidebooks for you. If you have any questions, please put them in the comments. Thank you. Have a good day.